We're talking about triangle proportionality. Sometimes people call this the side splitter theorem. So let's just fill in what it says first on the notes, and then I'll show you some examples. It says if there is a line that is parallel to one side of a triangle and it bisects the other two sides, then it divides the sides it intersects proportionally. And what that means is it causes a nested triangle. A nested triangle are triangles that look like this, where you have triangles inside of other triangles. And it says so you can have proportions of the small triangle to the large triangle. And so first we're just going to talk about which sides are proportional, and then we'll actually try to find some of the sides. So here it starts off by saying ID and IV. Okay? Alright, here's ID and here's IV. So it's saying that it's proportional to DE and then what other side. So the tops are the same, so ID goes with DE, that makes sense. And then IV here goes with EO. So this would be EO. So you're just trying to figure out what side it compares itself to. So here we have ID and DE again. Here it says DV. DV is the whole side. So the side it would compare itself to is the whole side on the other one. So DO. Okay, let's look at this one. It says AY. I want to look at the tops because sometimes they help me figure out the comparison. So AY and YE, okay. And then LA, well, which one over here does LA go with? Oh, it's ER. And I would draw a bunch of pictures for you, but if I draw those pictures, it'll be on my triangle, and then you won't be able to see all the others. So, all right. So this one we've got LY. But let's see what the rest of it is. It says PL and RS. So LY goes with whichever one it is over here, so that must be RY. You're just trying to find the one that kind of looks like it. So AY and an AE. So when I look at the two tops here, we've got AY and AE. Okay. Here it says YR. Oh, okay. So let's go back. AY and YR. We're going to skip this one. I don't think that this one makes sense. So we're going to skip that one. Okay. PA. And then AY. So PA, AY. So we've got like half of those sides. And then ES. Also, it should be this part here. So sometimes they write the comparison ones on top of each other, sometimes they're crossways. But basically you're just trying to find the one that matches with whatever else is going on in the problem. Okay? So let's look at some examples. So first of all, this right here shouldn't be here. This should say example 5 over here. Alright? It asks us to solve the problems, and here it's not obvious what we're looking for, but we're looking for this side here where that X is. So we know that corresponding sides compare, so what I would probably do is I would do 32 over 40 equals 24 over X. And that's what this proportionality theorem is telling us, is that the sides are proportional to each other when you have a triangle that looks like this. So to solve it, I'm going to multiply 40 and 24 together, and then 32 and X. So I've got 32X equals 960. Then I'm going to divide by 32, and so I get X equals 30. Okay, same kind of concept here. Looks like X is down here, but X is this side right here. So looks like we would have 8 over 10 equals 5 over X, cross multiply, so 8X equals 50, divide by 8. We will get a decimal here, and decimals are okay, although I know you don't like them greatly, they are okay to get. Now, example 5 is a little different. where it's looking for x is fine, but the thing that's different is the fact that you have the bases of the triangle. If you just are having the sides and you're trying to find the sides, then you just set up the proportions like this. But when it gives you the base of the triangle, you have to think of the actual two triangles. For example, I'm going to think of this little triangle here, and then I'm going to think of this big triangle here. Because I know that 8 and 20 are going to correspond together because they're the ones that go together, 8 over 20. But the problem is the part that it compares to is the side of the triangle. You don't just compare it to 5 and x, because x is not the side of that big triangle. So what we have to compare it to is the side of the orange, which is 5. And then we compare it to the side of the blue, which is actually 5 plus x. So that one's a little different how you have to compare it. It only happens when you have like the bases that you have to use. If I would have had to use these because they're the bases, or these, then I would have had to do it this way. That's the only kind of exception to this. So I'm going to cross multiply. This times this would be, make sure you do 8 times both, 40 plus 8x. And then 5 times 20 is 100. So subtract 40 on both sides. And then divide by 8. Let's look at number 6. Okay, number 6. So it tells us this whole side. But if the whole side's 8 and that's 5, I know that this part right here is 3. So I don't have to do what I did over there. I'm not talking about the bases or anything. I can just do the sides of comparing. So I'm going to do x over 5 equals 2 over 3. Cross multiply and solve. So 3x equals 10. Divide by 3. And so x is 3.33, or 10 over 3. Example 7. Alright, so what is it we're looking for here? I'm not really sure. I'm going to guess that we're looking for this side right here. Sorry it wasn't labeled for you, but we're going to look for that side. Notice that these are the bases. So this was kind of like this one where I have to look at this triangle and then I have to look at the big triangle. Okay. So as I look at the little triangle, I know that this part of the side is 27. And see, I'm not going to use that 36 because I don't have any separate information, but I know that this is 27. That means that this part right here, the whole blue side, is 27 plus 18, which comes out to be 45. So 27 over 45 equals x over the big one, which is 28. Cross multiply, so 45x equals, and then multiply 28 and 27 together. Divide by 45. Get that up so you can see that a little bit better. Okay, example 8. So let's look at the information here. It says for us to find WX, so that means I'm trying to find this part right here. That's good that I have 30 over here. I have a 12 there. That means I really need to know what this is. Well, if this whole side is 45, I can subtract 45 and 30, which is 15, which will give me that little part there. And then I can solve. So let's do x over 30 equals 12 over 15. Cross multiply, so 15x equals 360. And then divide it. Okay, that's the general idea. If you feel like you got it, you can stop the video at this point, but I am going to show you a few more examples just in case that it's helpful for you. So these 1 through 6 is kind of like the beginning of the worksheet that I was doing with you. So let's look over here. We have EF and FG, BA, EF and BA, FG, and so the one it corresponds to must be this one, which is AG. Okay? CB and BA. So it looks like we're going to go DE and EF, so this must be DE. You're just matching up the sides. Alright, EB and FA, and then it says FG. Alright, so when it says EB and FA, we're talking about like the bases. And since FG is here, we're going to have to do that whole side on this one. This one's kind of tricky. That's kind of like those tricky ones, the blue and orange ones on the other side. Okay? So EG and ED, and it says CB, so we're just comparing EG and DE. That must be BG. Okay? DC and FA, and then it says AG. Well, that must be, let's look at that one more time. DC, FA, and then AG. So FA and AG are of the little triangle. So when I look at the big triangle DC, I'm going to have to go on the big side of it. So that would be CG. Okay, last one. GF and FA, so we're looking at the little triangle. GD, so that must be the big one, DC. Okay. These others ask if the sides are parallel. So what you do is you find out if the sides are proportional, the way that we've been doing. If they're proportional, they're parallel. If they're not, they're not. So if I do 7 over 8, I should get the same as 2/3. If you put that in the calculator and put that in the calculator, you get, for 7/8 you get 0.875. And for 2/3, 0.667. That's not the same. So the answer is no on 7. It has to be the same. So here if I did 6 over 4, I have to equal 9 over 6. 6 over 4 equals 1.5. 9 over 6 equals 1.5. Because that's the same, then it is yes. So here we would do 3 over 3 3/4, and then 4 over 5. Okay, 3 3/4 is 3.75, so I'm going to divide by 3.75, and then 4/5. I do get 0.8 and 0.8, which are the same, so this is yes. And then lastly, it says determine the value of the variable to make it parallel. In order to do that, you just set it up the way that we have been and solve for x. So they're parallel as long as the sides are proportional. So 8 over x equals 20 over 25. Cross multiply, so you have 20x equals whatever 25 times 8 is. Divide by x, and so x is 10. On number 11, again, just compare x minus 4 over 12 equals 8 over 6. Cross multiply, be sure to do 6 times both of those. Alright, add 24 on both sides, and then divide by 6. So x is 20. Very last problem. So x minus 4 over x minus 5 equals 18 over 15. Cross multiply, 15x minus 60 equals 18x minus, we're going to do 18 times 5, which is 90. I'm going to subtract 18x on both sides, and I'm going to add 60, divide by -3, and then there is our answer.